In this tutorial, let's take a look at an RBDLab workflow where we would use initial velocities of the activator's module in a simulation. Let's use the simple mesh for destruction simulation. And here are the dimensions of this mesh. And under RBDLab, let's head to the Prepare tab and the Annotate to draw a fault line where we would like more fractures to happen. So start to annotate. And let's say this is the fault line. And annotation, scatter. Let's add standard scatter. And let's increase the density to something like 300. Accept. And let's use the source as own particles and Annotation Pencil with the max chunks at 1000 and noise at 0.05. Let's click on fracture. There we go. Now let's add extra details. And let's give a subdivisions of 3. And let's select all the chunks. And let's say select bad chunks. It'll just take a minute. There we go. So these are all the bad chunks. So let's click on auto fix. So that fixes all the bad chunks. Perfect. Now when we take a chunk and take a look at it, now we can see the internal details. Cool. Now let's click on apply and there we go. So let's go through the standard RBDLab workflow, which is adding ground and toggle the visibility. But before that, let's scale the ground a little bit more and toggle the visibility. And under RBD, let's add rigid bodies to these chunks. And under kinematics, let's click on kinematic and update so that the chunks would not move unless activated. And there we go. Chunks aren't moving. Cool. Now let's get to the activators module. And with the source as target collection and the layer type as kinematics, let's select the smaller chunks by using the size parameter here. There we go, something like that. And let's just deselect these chunks. And we don't need these. We don't need these. And we don't need these. Cool. So for these chunks, let's add kinematics layer. Cool. And let's add activator. And let's add a sphere activator. Now let's scale the sphere so that it roughly matches the thickness of the fault line. And let's give it a margin of 0.1 so that the activation will be very close to this sphere, and use single activation. And now we need to animate this sphere along this fault line. So for that, let's add a Bezier curve. Let's get to the edit mode. And let's turn on the X-ray so we can actually see. And let's press E to start extruding along the curve. And there we go. So now let's rotate and scale appropriately so that the curve is smooth. Cool. There we go. That's the curve. And now let's apply all transforms on the curve. And for the activator to follow the curve, let's select the activator. And under constraints, let's add a follow path constraint. And let's select the Bezier curve. And as we change the offset, the activator is going to move along the Bezier curve. Cool. Now let's, right there. Let's say at frame 10, let's insert a keyframe. Let's insert a keyframe as we are changing the offset. There we go. So let's take a look at the animation. Cool. Now that we have the animation for the activator, let's hide the activator. And let's hit record without changing any of the parameters from the initial velocity tab. So now we can see that the activator is activating these chunks, but the chunks aren't moving because we didn't give any direction to the chunks. All right, now let's start. Under directions, under constant mode, let's give it a z direction. Let's say 1.5 meters. And with the default multiplier of 0.1, let's remove and record the new keyframes. Now, as the activator is moving through, the chunks are being activated, as we can see. Perfect. Now let's see in a little more detail what the multiplier parameter does. Now let's increase the multiplier to something like 0.3. So this is a sort of a force multiplier to scale the movement of the chunks in the specified direction. So for example, let's give it 0.3 and hit record. There we go. We can see that the chunks are moving way higher. So that's how the multiplier works. Now we just need to make a small change here. So let's go to the scene and under rigid body world, under cache, let's change this to 300 frames. Perfect. So that's how the multiplier multiplies the force scale. Now, there's an option here, which is the offset. Now, when we use the offset, this offsets the animation. Let's keep the offset at 10 frames and hit the record button. Let's take a look. And there we go. As we can see, the offset parameter offsets the value experienced by the chunks, thereby giving more artistic control over the animation. So it might be helpful in some instances. So let's bring the offset back to 0 and let's take a look at what the ease in and out are. Now let's increase the ease in to 100% and let's record. Now here, the chunks would move less at the beginning of the animation, which is easing in, and then the chunks are going to move a lot more as the simulation is coming to an end. So that's what the ease in and out does. Now if we ease out at 100%, now this will sort of reverse the effect. So here we would see huge movement at the beginning of the simulation, And as the simulation progresses, we see less and less movement of the chunks. So that's the advantage of using ease in and out. Now let's take a look at the rotation. Now here, under constant mode, let's give a rotation of, let's say, minus 90. And with the multiplier at 0.1, let's hit record. So this would give some rotation to the chunks, as we can see. Cool. So this is under constant mode. Now let's change to the random for both the direction and the rotation. Now under random, let's say we would like to change the z value from a minimum of 1 meter to a maximum of 1.5 meter. So the chunks move randomly between these two values. And let's change the multiplier to 0.2 to be a little more realistic. And let's also change the rotation values for randomization between minus 90 and 90. And let's give it a multiplier of 0.1. And let's hit record. There we go. So some chunks are flying higher, some chunks are flying lower. So that's the advantage of using the random option. Under mesh visualization options, let's turn on pretty shading. And let's take a look at it again. Cool. All right. Let's turn the pretty shading off. Actually, let's also increase the multiplier value for rotation. Let's hit record. Cool. There we go. Perfect. Let's use this for the rest of the workflow. All right, so that's how we can use the initial velocity parameters. Now let's continue on with the workflow to the bake module, and let's bake. Let's change the frame end to 300 and let's bake. Cool. Now this would be a good point to save the file. Let's say bake. All right. And let's head to the particles. Now here, under debris, let's decrease the distance threshold and the velocity threshold and create debris. There we go. So with the default settings, let's take a look. So we can increase the size of the particles to something like, let's say 0.5 and click on update. Cool, this looks much better. And let's do the same thing for the dust. Create dust. Looks good. Now let's head to smoke and let's create smoke. Cool. Now for smoke, under emission, let's use end trails where we would like to have the smoke particles emitted for just 5 frames, and then click on Update. There we go. So those are the smoke particles. Looks good. Perfect. Now this would be a good time to save the file again. And this time, let's save it as particles. Sounds good. Now let's add collisions. Now for the collisions, if we have a close-up shot, then, for example, let's say we play the simulation. Now all these particles, which are the debris and dust, they're falling through the chunks, which wouldn't be very realistic. So they should collide with the chunks. So for that, there are a couple of options under the collisions module. So the first one is the collision to the chunks. So if we use this particular option, then we can add the collision to the entire collection or the selected chunks. And this is very useful if we are going for close-up shots. If we are going for a far-off shot, then we can actually use collision to static objects. And we know that these are the static objects. So we select these chunks by color and add static objects. So now the RBDLab is going to use these chunks for collision. So now with the default parameters, we can check the collision. And there we go. So we can see that the debris particles are colliding with the static chunks. If we look closer, let's take a look here. You can see that some of the debris particles are passing through the chunks. And for such close-up shots, we can use this collision tab, where we can add the collision to the entire collection or the selection. So this is computationally intensive, so just be cautious while using this particular option. For majority of the cases, this would look fairly realistic. Let's head to the mesh visualization options, and let's take a look at the pretty shading. Let's take a look at it now. There we go. Cool. So let's do a flipbook render. For that, let's change the viewport to high, and let's do a flipbook. So let's take a look at the flipbook render. Cool. Right. Now let's get back to the low resolution for the viewport. And let's move from the collisions to smoke. Let's bring back the overlays. And before we do that, let's save this file as collisions. Cool, let's move to smoke. So as this is a simple simulation, we can directly move to smoke. But let's say if this is a fairly complicated simulation with a lot of computations to be carried out for collisions, then what I normally do is to bake the particles. So let's bake all the particles. So even the collisions are baked. Cool. And then I go back to the collisions module and then remove the collisions. So there are no more collisions. So this would be a bit faster. So this would be more efficient on the computation. And for this one, I would save this as collisions removed. Actually, collisions baked. Perfect. Now let's move to smoke. Now we can add smoke from mesh or from particles. Since we already have the particles baked, let's use from particles. And then let's add smoke. Now let's select the domain. And let's head to the last frame. And then scale the domain appropriately. Something like that. And let's move the domain. Cool. Now let's take a look at. So let's get to edit mode, select the top face and move it up a bit. All right, there we go. Much better. Now under resolution, let's give it a resolution of 64 for testing purpose. And collision, bottom, for the border collisions. And for the gas, let's give it a buoyancy density of -1 and heat of 0 and vorticity 0.25. And let's use 10 frames for the dissolve option. And under cache, let's select all and resumable. And let's say file, save as smoke. Now let's bake. And let's see how the bake is going. Cool. All right, not bad. Let's resume. All right, let's take a look at it. Looks good. And if we are interested in higher resolution smoke, we can actually add noise to the smoke domain. So here we can say use noise. When we use noise, it will upscale the resolution of the noise of the smoke. So let's use noise. Let's first go to cache, free all, and let's do a final bake at a resolution of, let's say, 256 and upres of 4. So this is going to take a while. Actually, let's do one small change. Under resolution, let's change the threshold to a very small number. There you go. That should be good. Now let's bake. All right, the bake has been completed. Let's take a look at the flipbook render. Let's disable the particles from the viewport. And let's do a flipbook render. All right, let's take a look at the flipbook render. Now let's take a brief look at the shader editor. Let's click on the domain and we can see the shader here. And we can change the color right here. We can increase or decrease the brightness. And the density we can control using this value here. Cool. And we can also change the color of the smoke. Cool. Thank you for watching and stay tuned for more tutorials.